Today I'm gonna walk you through my proof of linearity. Today I'm gonna walk you through my proof of a problem using linearity of expectations. So we want to solve this problem over here, or we want to prove this. And by this, we suppose that and the problem goes like this. Suppose that n people sit in a circle, and each person has a quarter and a pretty feather. Simultaneously, each person flips their quarter. If it lands heads, they give their feather to the person on their left, and if it lands tails, they give their feather to the person on their right. Use linearity of expectations to show that the expected number of people who end up with no feathers is n/4. So because we're using linearity of expectations, we gotta set an indicator random variable. Setting an indicator random variable help us focus on specific individuals. So when I set my indicator random variable, I said that x is equal to 1 if an individual does not end with a feather, and 0 if they do, because we're calculating the number of individuals that do not end up with a feather. So then we can calculate e to the x. So we know that the expected value is equal to the sum of the probabilities of every individual by using linearity of expectations. So we're using this as a tool. We know that this property helps us get the expected number of the whole sample. So yeah. We also know that the probability of an individual to not end with a feather is 1/4, since the probability for the person on the right to pass it right is 1/2, and the probability of the person on the left to pass it left is 1/2. So yes, we know that it's either heads or tails. So we want the person to the right to pass it right, so that it doesn't pass it to the individual we're calculating, and we want the person on the left to pass it left, so that they don't pass it to the individual we're calculating. If both of them don't pass it to the individual we're calculating, that's what we want. That would be x equals to 1. So yes. And we know this is 1/4 because these are we want the joint probability. We want the joint probability of both of them happening. So that would be 1/2 times 1/2, which is 1/4. So now that we know that applies for every individual, we know that by linearity of expectations, that would be the sum of 1/4 plus 1/4 plus 1/4 until n. So that becomes n/4. Thank you.